Okay, Assalamualaikum everyone. Okay, so this is actually a recorded video and this is a continuous session. Okay, after our previous lecture. Okay, so we have started on solving second ODE using YC plus YP. Okay, the complementary function and the particular function. Okay, so I have discussed example in ebook of John Berg. Okay, for A and B, so I'm going to explain today on part C. Okay, so in ebook, I'm going to explain example in problem 456. Okay, so let's go to the problem number 4. Okay, so in this problem number 4, this is the second ODE. So see that on the right hand side is not equal to 0, correct? So this is second ODE non-homogeneous. Okay, so we have to identify first. This is a non-homogeneous second ODE. Okay, so remember the previous step. So in this question, we have boundary conditions given. So it means that we need to find out what is the particular solution. Okay, so first step, we are supposed to write down this equation into auxiliary form. So the one in auxiliary, this is the equation, is m squared minus 2m plus 1 equal to 0. So you can check what is the value from your calculator. So we have m that is equal to 1. Okay, so the roots for this quadratic equation is repeated. So we are supposed to write down what is the YC. Here, when the roots is real number and is repeated, equals to this part 2. So I'm going to write down here AX plus B okay, so we have here as A X plus B e to the power alpha, in this case is 1. So I'll just write down here. Okay, so this is our complementary function. Okay, so we have identified what is the complementary function, and then we are supposed to refer to the one on the table. Okay, so the right hand side that we have is the e to the power 4x. So it is a function in terms of exponential. Then we refer to the table regarding the one on the right hand side. Okay, so there are 3 types if you want to see. Before we proceed to the one regarding the particular function for the example, okay, in problem number 4, I'm going to explain on which particular function that we are going to use. Okay, what is the difference between this one, and the third one. Okay, so for the first part, first case. Okay, so this one we use the particular function when this the one in the complementary function ex appear only one time. Okay, which means that it's appear in the complementary function. Okay, for this case, we are going to use this particular YP. Okay, so remember in previous class, in this ebook using V as the symbol for particular function. Okay, but I'm using YP. Okay, for this part, we will use this particular function YP when our EAX. So this comes from our the one in the auxiliary, okay, it appeared in the complementary function. We're going to use this particular function when the same EAX, okay, appear in complementary function at both constant. So let's say in the complementary function we have constant as a, b, okay, and then this EAX appear in a and b, okay, when we times out or open the brackets, and this the EAX also appear in the right hand side of the original second ODE. Okay, so we'll be using these types of particular functions. Okay. Okay, so for this case, I'm going to write down something so that you can see clearly. Okay, so this for YP example. Okay, so let's say the YC is this one. Okay, so let's say this one. This is YC. And the right hand side, this right hand side is in the original second ODE. Let's look at what is the factor. Okay, so for example, okay, so means that these roots is different. So this is e power 1x, so this is e power 4x. So we use this YP. Okay, so if for this case, okay, let's say here we have the YC is A E 3/2x plus B E negative x. And the right hand side of the equation, in the original equation, let's say the right hand side is e to the power 3/2x. Okay, so it's appear, say this one, the one that I underline, it appear on these two sides. Okay, so for this case, we use YP, which is here. Okay, compared to the first one, let's see that they are different, right? So you can compare. Okay, for this one example, let's say our complementary is ax plus b. Okay, then we have e2x. Then the right hand side, there is e2x also. Okay, so this appear two times when we open this bracket. So this e2x appear at the both constant at A and also at B, and it's also appear on the right hand side of original second ODE, okay, non-homogeneous type. Okay, so for this case, we are using this part, this YP, okay. So I hope you can see what is the difference when to use the particular function. Okay, so we go back to the one in the problem number 4. Okay, so we have already find out what is the YC. So this time we need to look at the, okay, so this is our YC, e power x, right? But the one on right hand side is e power 4x. So they are different part. Okay, so the YP will be based on this one. So we are going to use this one, YP as KE. So in this case, our A is 4. KEAX. So our YP will be KEAX. A will be depend on the right hand side. So our case will be E4X. Okay, so to continue, we'll use here. So I'm going to write down here YP as KE for X. So differentiate here. Therefore, KE for X. Second derivative. 16 KE for X. And then we put into the original ODE. So we have 16K. For KE for X. Okay, so this time we have 16K. Open the bracket. Okay, so then simplify 16K minus 8K. Then we have 8K plus 1K. So then we have 9K. Okay, so this part they are equal. So we have K that is equal to 1 over 3. So our YP is 1 over 3E for X. Okay, so our Y is equal to YC plus YP. So our YC is, previous one is EX plus B. E power 1X. Okay, then plus YP. So we have 1 over 3E for X. So this is our general solution. So if we want to find out what is the particular solution, then we substitute into the value using the given boundary condition. Okay, so for the particular solution, I hope you can continue. Okay, so I'm going to proceed to question in problem number 5. Okay, so this is the question. Solve. So in this question number 5, there is no boundary condition given. So it means that we need to find out the general solution. Okay, so first thing, the second ODE, the one on the left hand side, write down the auxiliary equation as so we have here as 2 m squared minus m minus 3 equal to 0. Okay. So you can check what is the value in your calculator. So we have this one. So the roots are real number and different. Okay. So our particular solution will be this part because of the roots are real number and different. So I'm going to write down again. So our YC is equal to AE 3 over 2x plus BE negative x. Okay, so now we want to find what is YP. Okay, so look at the exponential factor, the one on the right hand side. Okay, so the one on the right hand side is, we have this part, E3 to X. So there is a same factor appear in our constant A. Okay. So in the table, we are going to use this one. Okay, so I'm supposed to use this kind of particular function. Okay, so just need to write down what is the value of A. In this case, our A is 3/2. That's why our particular solution will be Kx e to the power 3/2x. So this time I'm going to write down here Kx e to the power 3/2x. Okay, why 3/2? Because this part appear in the complementary function and also on the right hand side. Okay, so we use this kind of exponential. Okay, so find the first derivative. So we have this, there is here. Okay, so I'm going to write down here Kx and then differentiate here. So we have 3/2e 3/2x plus the other part, differentiate x, so we have k and e 3/2x. Okay, continue differentiate this for the second derivative. So here, take kx, differentiate the one here. So we have 9/4 kx and then plus take the one in the bracket. Okay, differentiate this one, we have k. Okay, and then differentiate this, combine. So we have 3/2 k e 3/2x. So we have first derivative, second derivative from the yp, and then we substitute into the original equation that we have in the equation that is here. Okay, so we have the expansion of so we have the 2. So it will be cancelled out because we have 9/4. So I mean that this part will be times 2. Okay, so we have, I will just directly write down what is the simplest part. 9/2 kx e 3/2x and plus 3 e 3k 3k e 3/2x plus 3k e 3/2x. And then we have minus. Okay, so we have minus kx we have minus k. So this is, so 1 simplify with minus and plus will be minus. Then minus 3y minus 3y, which is here. So we have 3k kx. Okay, then equal to the one on the right hand side, 5e. Okay, so this time we have to look at, is there any part that we can combine them? So this one will be combined with here. Okay, so here 3KE. So can be combined here. Can be combined here. This one also can be combined. Okay, so follow the combination. Okay, so we have 9 over 2 minus 3 over 2. So we have 6 over 2 that is equal to 3kx. Okay, so 3kx minus 3kx, so that will be 0. So this part is missed. Okay, so now we look at here. 3ke, 3ke, then we have 3ke, then we have minus 1ke. So we have 6 minus 1, 5. Okay, so I have 5ke 3 over 2x. Then let it equal to the one on the right hand side. Okay, so this one is now equal. So 5k is equal to 5. So it means that our k is 1. Okay, so we have here yp as x e to the power 3 over 2x. Okay, so finally we write down y as yc plus yp. So the complementary is here. Then plus yp xe 3 over 2x. So this is the general solution. Okay, so now we see problem number 6. Okay, so problem number 6 is here. So this is problem number 6. So on the right hand side, non-homogeneous. Okay, so first we write down auxiliary form. Okay, refer to the one on the left hand side only. Okay, so in the auxiliary form, this is being written as m squared minus 4m plus 4. Okay, so you key in the value in your calculator, get the solution, and we will find out that the roots for that quadratic is m equal to 2. Okay, so the roots are real number and equal. So this is the YC. Okay, so you may refer to the one from the guideline. Okay, and then to determine what is YP, okay, so let's see our E to X, okay, appear in A and B, okay, appear when it will be appear when we times out or open the brackets. Times out, that is this E with B and A, so E to X appear in the both constant. Okay, now when we refer to the one on the right hand side in the original equation, so e to x appear in our right hand side also. Okay, so we are going to use the third form in the table. So the one in the table is here. We are going to use one. Okay, so this is our kx squared. This is our yp. So we use kx squared. So this a will be our 2. Okay, so next, once we determine what is the yp, okay, so this is yp. Okay, so differentiate. So I'm going to write down here yp kx squared e 2x. Correct? Okay, so differentiate this. So take here, differentiate e. Okay, plus take e, differentiate another one. So we have 2kx. Okay, then another second derivative. we do similarly. Okay, take this one, differentiate in the one in the bracket. So I have 4 e to x plus take the one in the bracket, then differentiate the other side. Okay, plus another part, take this one, differentiate the one in the bracket. Okay, plus take the one in the bracket, differentiate the other one. Okay, so let's look at the other part that we can simplify. So I have 4k x squared e to x. Okay, 4k x squared e to x. So this will be 4kx. Okay, this one will be 4kx. Then I have another one that is 4kx here. Okay, so 4kx e to x. So 4 plus 4, then I can simplify to 8k x e to x. Okay, and then plus the other one. 2k e to x. So this is our double prime, second derivative. So in the original equation, now we refer back. Okay, so this is the equation. So once you substitute into the original equation, I have second derivative first. Okay, 4kx squared then minus 4. Okay, so in the original there is a minus 4 with everything in the first derivative. Okay, minus 4 is here. First derivative is here. So minus 4kx squared. Okay, so there is a 2 here. Okay, so 4 times 2. Okay, I will times out directly. So this one I'm going to change it. So 4 times 2 is 8. Kx squared e to x. Okay, and then minus 4. So this will be times 4. There is 2. So I have minus 8kx e to x. Okay, so this is for the first derivative when it times out with the value of negative 4. Okay, and then we have plus y. So plus y, 4y. So this will be times out with 4. So I have 4k x squared e to x. Then equal to the one on the right hand side, which is 3e to x. So I have 3e to x. So let's look at is then the part that we can combine. So look at the same factor. This is x squared. So I have kx squared. Then another kx squared. Okay, so 4kx squared minus 8kx squared. I have negative 4kx squared. And I have plus 4. Okay, so negative 4 plus 4, I have 0. So this part is vanished. Okay, next is the kx. Okay, so I have this one, kx. And I have also kx. So this part will be 0 also. Because 8kx minus 8kx will be 0. Okay, then I have this part left. Okay, so this will be written as 2k e to x. Let it equal to the one on right hand side, 3 e to x. Okay, so this one is equal, compare. Then I have 2k that is equal to 3. So this gives us k as 3 over 2. Okay, so our YP here is 3 over 2 Okay, 3 over 2x squared e 2x. Okay, and then final step is to write down what is the general solution. Okay, so our YC is just now okay, EX plus B. EX plus B E 2x. Okay, so this is YC and then plus our YP here. 3 over 2 x squared E 2x. Okay, so this is a final answer for general solution.